For this video, I will be working out section 11 4b, number 19, and number 20. Number 19 says, for each of the following figures, find v plus f minus e, where v, e, and f stand respectively for the number of vertices, edges, and faces. Now looking at figure A, right there, we're going to first find the vertices, which are the points right on where the lines connect, so the corner pieces, I like to say. So if we count all of those out, we come to have 10. So I'm just going to write that down. 10. Now we're going to count the edges, which are the straight lines where the two faces connect. And so counting the edges out, you find that you have 15. So we're going to write that. I made a little table so that we could easily decipher which one is which. Now for the faces, that's the whole sides right here. And so counting them out, we have about 7 faces. So we're going to write that in our little chart. Now for A, we're going to go down and we're going to do the Euler's formula, which is vertices plus faces minus edges. So we're going to do vertices, which was 10, plus faces, which was 7, minus edges, which was 15, and 10 plus 7 equals 17, and then minus 15 equals 2. Now we're going to look at figure B, and we're going to find the vertices, edges, and faces for that one as well. So for the vertices, the little points, like I said, you count those out and you get 9. So we're going to go to my little handy dandy table right there. And then we're going to count the edges, which again are the lines where the two faces connect. And after you count all those, you come out with 16, like that. And then for the faces, those are the big spaces right on each side. You count all those out and you get 9. Now we're going to do Euler's formula again. So for vertices, we had 9, and then plus faces was 9 again, and then minus edges, which was 16, equals, so 9 plus 9 equals 18, and then minus 16 equals 2. And for the Euler's formula, we find that the answer is always going to be 2, no matter what. It's always going to be 2. Okay, now moving on to number 20. It says the polyhedron below has 14 faces made up of 8 triangles and 6 octagons. How many vertices does it have? So on my paper I wrote octagons, they have 8 sides each, and there are 6 octagons on the polyhedron. So we're going to do 8 times 6, and then there's also triangles on there, and triangles have 3 sides, and there are 8 triangles. So we're going to plus 3 times 8. And so 8 times 6 equals 48, and that's plus 3 times 8, which is 24. And that comes out to be 72. And then we're going to try and find half of 72. So if you divide 72 by 2, that will equal 36. And this is how many edges there are. So now we're going to do the Euler's formula again, which was the v plus f minus e. Okay? And so we know that we have 14 faces. It said that in the problem. So we're going to add that in right here for where the faces is. 14. And then v plus. And then I'm actually going, like we said, it equals 2. So I'm actually going to add the e to both sides to make it a little easier. So it's going to equal e plus 2. So, and then we know that edges is 36. So the formula that we have to work with now is v plus 14 equals 36 plus 2. Okay? So if we take 36 plus 2, we get 38. 38. Okay, and then we're going to minus 14 on each side. So V will equal 24. So on this polyhedron right here, it has 24 vertices.